One more cross-validation technique that is called bootstrapping. This is one of the most widely used technique once again. Bootstrapping has many applications. It can be used for cross-validation also. It is a very unique method and it definitely gives a good idea on the overall error. It can be used for model building and building very stable models, and it can be, I mean, the results out of bootstrapping can be trusted and accepted very easily. So what exactly is bootstrapping method? So what we do, I mean, bootstrapping, the main usage is it clearly gives a real good estimate of future performance of the model. So whatever is the training data, whatever is the testing data, if we use bootstrap cross validation, the final error that we get out of bootstrap cross validation, that will be the real error of the model, and it will neither be lesser or nor be more. So what exactly is bootstrap algorithm? So we have been doing tenfold, k-fold cross validation, right? We are taking 90% of the data or 80% of the data, using rest 20% for the validation. In bootstrapping, we take the data in a slightly different manner. We take bootstrap samples. Let us suppose if the training data size is n, let's say if there are 100,000 observations, then we draw a random sample with replacement of size n. We draw 100,000 samples, but how do we do it? We'll do it one at a time. We take a sample point and we note it down. Again we put the sample point back in the data set. Again the data set is 100,000. Again we take one more sample from it. Like that we repeat this whole process 10,000 times. Then we have a very new data set, because we have taken it by doing sample with replacement. In that new data set, some observations might repeat twice or thrice, and some observations might not have picked at all, because we are doing the sampling one at a time. But though we have picked the whole 10,000 observations, but some of the points might not have never chosen, or some of the points might have chosen twice or thrice. So that is one bootstrap sample. So one bootstrap sample of size 100,000, whatever is size of the data set. If we do this, 10 such samples or B such samples, then those are called B bootstrap samples. Then what we can do is, now instead of one training data set, we have 10 or B such training data sets. On each of the training data set we can build a model, and then we can test the models on the original training data set and get an idea on the overall accuracy of the model. Once again, how bootstrap samples are taken: we have a training data set of, let's say, 1000. Then what do? We take a sample of 1000 with replacement. That means we take one point and put it here, then, or note it down, and then we put that one point back. Again we take 1 point sample and then do that 1000 times. That means we take a sample of 1000, but not 1000 at a time, we take one at a time. So in this 1000 observations, there can be some observations which are repeated twice or thrice. There can be some observations which are never picked. Now that is bootstrap sample 1. Again we do that bootstrap sample 2. Now this data set might be entirely different from this data set, which are again picked from training data only. Again we do that bootstrap sample 3. So like that we pick B bootstrap samples. On each of them we can build the models. It is a very calculation intensive process, but at least we will, at the end of this, we will get the true training error, true testing error, and the true accuracy of the model that we are building. So once again, so this is the overall a simple example of bootstrap sample. Let us suppose we have a training data of size 500. So what do we do in bootstrap dataset 1? We create a dataset of size 500. How do? We increment it one by one. To create that dataset, draw a random point from the training data. note it down, replace it back in the training data. Again draw another random sample point. Repeat the process for 500 times. This makes a dataset of size 500. This is one dataset of size 500. Call this bootstrap dataset 1. Multiple bootstrap dataset. After doing bootstrap dataset 1, repeat this process again and again, let's say 200 times. Then we have 200 bootstrap datasets, or we can repeat it 10 times. Then we have 10 bootstrap datasets, each of size 500. Then we can build the models on these 200 bootstrap samples or those 10 bootstrap samples, find the average error. Now that gives a very good idea on the overall error. The results coming out of bootstrap sample are very solid and they are very consistent. We can definitely believe the actual accuracy or the error. In fact, we can consider that as the final accuracy of the